Okay, this is going to be a quick tutorial on how to complete an ion chart that has a column for charge. So it's a little bit different than what we did earlier in the week. So you're going to need a periodic table to help you with this homework. But I'm going to start the first two rows with you. So the first thing to tackle an ion chart is to remember that whenever you see a number sign like this, what I mean is an atomic number. The atomic number is the number of protons, and that determines the element. So since the atomic number is the number of protons, this column and this column will always be the same. They're going to be identical in your homework, in your ion chart. Okay, so since we're dealing with number 10, we look on our periodic table and notice that number 10 is going to be neon. So we're going to go back to the chart. We're going to write Ne. We're going to write neon. It's number 10. We'll get to the charge in just a moment. But notice the mass. Okay, we're going to need to use the mass to do that quick subtraction problem to find the neutrons, because the mass is the protons plus the neutrons. That's the total mass. The electrons don't matter when you're calculating mass. Proton number is going to be the same as the atomic number, so we're going to put a 10 right there. We're going to skip electrons for a second, and we're going to go to neutrons. Now notice you got 21 minus 10. So that's going to give you your neutron count of 11. So we're going to put 11 right there. All right, now to figure out our electrons. I want you, for the electron count, I want you to put like a big minus sign right above this column. And for the protons, just do a big plus sign, just so you don't get confused. Remember, the neutrons don't have a charge. So since these are negative, and you want to find the count, you got to look at this charge. What this charge means, what this is saying, is that the overall neon atom has a positive 2 overall charge. That means it's got 2 more protons than electrons. So you do a quick simple math. 10 minus 2 is 8. So what this is saying is that you have 8 electrons and 10 protons. You have 2 more positives than negatives, so your charge is plus 2. This is an ion. Why don't you go ahead and write down way over here whether it's an ion or not. So we're just going to write, yes, it's an ion, because it's charged. Some of these might have a charge of 0. Actually, I'm looking at my key right now, and none of them have a charge of 0. So they're actually all going to be ions, so you don't have to write that. They're all going to be ions. That means that they're all going to have a charge. When you do your atom model project, you're making a neutrally charged atom, which means your protons and electrons are going to be the same count. But in actuality, that's not really true. You're not going to really have an equal amount of protons and electrons, but we're just going to keep it simple for our first project. Let's move on to the second line right here. Okay, so this is going to be just like a little puzzle. We have empty, spaces, but when you come over to the proton column, you see that you have 5 protons. So that's going to tell us that your atomic number is going to be 5. If your atomic number is 5, look at your periodic table. You got 1 for hydrogen, 2 for helium, lithium's 3, beryllium's 4, boron is 5. So come over here and write boron and put a capital B. Okay, we can do this column right now because we know our proton count and we know our electron count. And if you want, just put a little plus in the proton column and a minus next to the number in the electron column. Compare these two numbers. You see that you have 1 more negative than positive. So the charge for this boron atom is going to be -1. That means it's going to be a negative atom, a negative ion it's called. To figure out your neutrons, you do that simple subtraction problem. You take your mass, you subtract out your protons, and you're going to get your neutrons of 9. Why don't you do me a favor at the top of this worksheet? Why don't you write the formula? Atomic mass is calculated, so it equals protons plus your neutrons. And if you want to figure out neutrons, you just take atomic mass minus protons. So I'll do that really quick. Mass minus protons will equal neutrons. Okay, so you should just start remembering that And then this goes with the proton column. Okay, so you might be asking yourself, why is there another boron down here? You are going to have repeat elements. You're going to see another neon down here as well. And the reason why is because these two boron atoms are isotopes. And what an isotope is, it's when you have the same proton count, because boron is number 5 always, so I'm jumping down to row number 4. Boron is number 5, so it's going to have 5 protons. Okay, but why is it repeated? There's something is making it repeat, and it's the reason why is because it's an isotope. It's going to have a different mass, and the reason why it has a different mass is because of the neutron count. So let's look at the protons. We got 5 for boron. Add 2 more, and you get a total mass of 7. Now look at that one you did on the second row. The second row you had a mass of 14. So these are 2 different masses. That means they're isotopes each other. They have the same proton count, but their neutron count is different. And it means that they are isotopes. Let's finish this row off by figuring out our electrons. You have a -2 charge here. So remember, these are your positives. You want to figure out your negatives. If you have a -2 charge, that means you have 2 more negatives than positives. So think about it. What's the answer? 7. You're going to have 7 electrons, 5 protons, which will give you a charge of -2. Okay, don't forget about row number 3. I just skipped it, but I think you can handle this now. Complete the whole worksheet and turn it in next time I see you in class. Thanks for watching.